Functional programming is a paradigm where development is based on creating and composing functions. Lisp was the first high-level functional programming language developed in the 1950s. This paradigm evolved from lambda calculus, a mathematical system for expressing computation based on function abstraction. It's focused on what to solve rather than how to solve by defining the problem using declarative functions. Functional programming has the following foundational principles. Pure function. It's a function that produces the same output given the same input. It has no side effects because it doesn't have an external impact. Immutability. Once the data is created, it cannot be modified. It preserves the initial state and prevents side effects. New data can be added by applying functions to existing data. First-class function. It's a function used in different ways. Variables, parameters, and return types can be expressed as functions. Everything is a function. Higher order function. It's a function that accepts functions as arguments or returns them as a result. Multiple functions can be used in function composition like pipelines. Other relevant concepts in functional programming include recursion and referential transparency. Functional features can be applied in multi-paradigm languages. For example, Java SE8 introduced lambda expressions to represent methods as expressions. C# includes LINQ, which is a form of declarative functional programming. JavaScript code can be developed using functional programming. How? Let's go to the demo. Welcome everyone. We will apply functional principles on JavaScript. So let's create an empty JavaScript file. In this example, we will filter numbers from an array based on a sequence provided by another function. To accomplish this, let's create a variable called selectedNumbers. That is a function that takes two parameters, an array and an argument function. This function filters the array elements based on the function parameter. Here comes the first functional principle, a first-class function. A variable expresses a function. Include two sequences as functions, even numbers and odd numbers. Declare an even property as a lambda function to validate if the number is even. Declare it as a constant. I will explain later. In the same way, add a property for odd numbers. Notice that even and odd functions depend on the residue of applying module to a number. So we will create a module to function to verify the residue and reuse it in the above functions. Reuse it in both even and odd functions. This is the second functional principle, higher order functions. The selectedNumbers functions accepts an argument function, and the argument function can depend on another function. Also notice that I declare only constant variables to apply the third functional principle, immutability. Once the variables are declared, they cannot change. Now let's print the results by console. Add a new sample array, call the selectedNumbers function, pass the array, and print even numbers by using the even function. Similarly, print odd numbers. Add the return keyword. Awesome, we have our two sequences, odd numbers and even numbers. Run again. Here comes the last functional principle, pure function. No matter how many times we pass a particular input, the output is always the same. What are the benefits of functional programming? Expressiveness. Small, declarative, and human-readable functions designed to do one thing and do it well. Debugging and testing. Purity and immutability make it easy to reproduce bugs and write unit tests to validate the expected results. Concurrency and parallelism. With no side effects or shared mutable objects, multi-threading issues such as race conditions are not applicable. Laziness. Functional programming encourages lazy evaluation, meaning that expressions are only evaluated when they are requested. Modularity. Granular, isolated functions are easier to maintain and promote reusability. Caching. The determinism of pure functions allows results to be stored once for given inputs and reused whenever the same function parameters are passed. And the drawbacks. Statefulness difficulty. Challenging to work with mutable states and interactive tasks such as I/O operations. Functional misunderstanding. Ineffective application of functional key ideas like recursion can lead to infinite loops and memory overheads. Performance trade-offs. Although functional programming can be more expressive and elegant, it might not be the most performant choice for certain use cases. If you want to learn more, don't forget to subscribe. May the code be with you.